Swayam Prabha. Digital India. Educated India.
Hello everyone. In the previous class, we learnt about the equal area projection, we learnt about the stereo net, and we saw that how a plane can be represented by a great circle or a pole. So today we are going to discuss about the projection for the intersection of two planes. Then we will try also to see how to find out the angle between the two lines. So let us start with that. Again we will be making use of the stereo nets. I will be taking you through a stepwise procedure to enable you to do these things on your own with the help of a stereo net and a tracing sheet which are pinned at the center. So you see that when you have two planes, so here in this case those two planes have been shown by these hashed portions. So you can see that this is what is what are the two planes. This is the first plane and this is your second plane, and we already know that these two planes, how they can be represented if they have to intersect the sphere. So this is how the intersection will look like. Now you all know from your engineering graphics background that when the two planes they intersect, the result is this line. So this is what is the line of the intersection. How to do this? How to plot it as a form of the geological data? So there are two planes which are given. One is dipping in 50 degree and with a dip direction of 130 degree, and another one has 30 degree and a dip direction of 250 degree. So basically the first part, that is this plane, that is one dipping in 50 degree in a dip direction of 130 degree, that we have already seen in the previous class. So today what we will do is we will plot in that figure only, we will plot this additional plane, and then we will try to see the line of intersection, how we can determine that. So you see that this one plane has already been drawn. So let us see that how we can draw the next plane which is having a dip of 30 degree with a dip direction of 250 degree. So we have to follow the same procedure as we did in the previous case. What we need to do is we need to measure 250 degree along the circumference, then we need to rotate it in such a manner that it coincides with west east axis, and then we will trace the great circle corresponding to a dip of 30 degree. Let us see how we do this. So this is the one plane which we already have seen in the previous class how to draw. This is the one plane. Now see, north is coinciding with 0 here and it is in the original position which is pinned at the center. So from here in the clockwise direction I come and then I mark a point as 250 degree having the dip direction of the other plane. Now the next task is going to be this 250 degree mark which is there, I need to rotate it in such a manner that it coincides with this west direction, okay, or 270 degree. So this mark and this has been rotated. So you can see that the north has been rotated by 20 degree, likewise east, south and west. So what is happening? the 250-degree mark which was there here at this location is now here at this location, this 250-degree. Now, because the dip is 30-degree, so as I explained it to you in the previous class, from this outer surface you will take 30-degree towards the center. So, this is your 10, 20 and then this is your 30-degree. See, this is what that we have done. So, corresponding to this 30-degree, I draw another great circle which will be representing the plane having dip as 30-degree and dip direction as 250-degree, and obviously this plane is having 130-degree dip direction and 50-degree dip as we have seen in the previous class. So, we have these two planes. So, this is how it will look like. This is here, your north is there, south, east and west. Keep a track of this, keep that in mind. I am not rotating the stereo net. Its position is always here, like this is what is 0 and this is what is 180-degree. What I am rotating is only the tracing sheet. Now, you see what is done in this case, wherever point that these two great circles they are intersecting, we rotate the tracing sheet such that the intersection of these two great circles they lie along this axis, that is west east axis of the stereo net. So, this is how we need to do. So, the point of the intersection was this point and we have rotated in such a manner that it is lying along, you see, this 270-degree and 90-degree point here. Now, how to determine its dip and the dip direction? So, you see from the extreme circle, you just measure off this distance, radial distance. This is 10, 20 and little bit more than 20. So, that is going to be 20.5. So, you see it is this distance which is, this is 20.5 degree. This is what has been shown in this figure which has been taken from the book by Hook and Break. Then what we do is, we rotate the tracing back to its original position such that the north of the tracing sheet coincides with the north of the stereo plot. So, you see that this is how it will look like, and then we draw a line from the center joining this point of intersection, that means this line. This is how that it will look like. Here I have drawn this line and the north is matching with 0 of the stereo net, south is matching with 180-degree, and automatically the circle on the tracing sheet is on the circle of the stereo net. They are coinciding with each other. Now, you see wherever this line is intersecting the circumference, that is here, can you read it like this is 180-degree, 190-degree, this is 200 and little bit ahead of the 200. So, this is what is 200.5. So, after getting this, like whatever is the line of intersection of these two planes which is represented as this particular point, that line will have its plunge and trend, and this is how you can determine it. So, this has 20.5 and 200.5 degrees of the parameters with respect to line of intersection of two planes. So, this is how it is done. So, let me repeat all the steps once again. First of all, you draw the two planes representing by their great circle. Wherever the great circle intersects, that point will represent the line of intersection of these two planes. how to determine the plunge and the trend of these lines, you have to follow the standard procedure that has already been explained. Now, coming to the next problem, that is the determination of the angle between two specific lines. So, in this case again we will make the use of the stereo net and the tracing sheet. So, here we are taking the two lines with plunge of 54 degree and trend of 240 degree, that is line number 1. Then the second one is the plunge of 40 degree and trend of 140 degree, that is line number 2. So, these two lines, they may represent the axis of tunnel or anything, or they can be the normal to any planes. Okay. Now, the question is how to determine the angle between these lines. That is the question's answer that we are going to find out in subsequent slides. So, in this case again we will do that first step for all these stereo plots, it is going to be the same. You place a tracing sheet on top of this stereo net, draw the outline of this circle, mark 0, 180 degree, 90 and 270 degree on the tracing sheet. Now, here you see the trend of the two lines, which is, I have already told you that which is equal or equivalent to the dip direction. So, you see in this case it is 140 degree and 240 degree. So, from the north in the clockwise direction, I will mark 2 points, that is 140 degree and 240 degree, and join it with the center of this circle. So, that's how we are going to make use of this. So, first of all we have this trend. Now, the question is how to locate this point A and B. Let us see. So, what is done here is we have this line 140 degree mark which was there. I rotate the circle so that 140 degree is matching here, and then I count from here, like 54 degree was the angle. So, 10, 20, 30, 40, 50 and then 2 marks. So, I will mark here this as A. Similarly, for this point B again, so I have that two lines, one was for 140 degree and another one was 240 degree. So, this is what that we did with 140 degree. So, now coming to the next one, that is 240 degree. So, again the same thing that we are going to do. So, I have rotated the tracing sheet in such a manner that that particular mark corresponding to 240 degree is coinciding with this west east axis, and then from here, that is from this outer circle, you see here to here, this point I count 40, 1, 2, 3, 4 and each are having 10 degrees of measurement. So, this angle being 40 degree. So, I mark this point which is B. So, you see that we have these 2 points, one is A, another one is B. These are representing the two lines. I rotate it back, that means coinciding north with the 0 degree, and accordingly south, east and west they will be coinciding with the respective angles. This is how the plot is going to look like. So, these two lines I have represented with the help of the points A and B, which were having some trend and some plunge. Now, how to determine the angle between these two lines? So, what is done in this case is, we need to rotate the tracing sheet in such a manner that these 2 points which we have marked A and B, they lie on the same great circle. And then what we do is, we measure that how many points or how many interval are there in between these 2 points along that great circle, not along horizontal direction, not along vertical direction, but along that great circle. That angular distance is going to give us the angle. Let us see how we do that. So, you see I rotated this tracing sheet in such a manner that the point A and B, they were lying on the same great circle. So, the moment it happens, I mark that great circle here with the help of the pencil, you see, like this. Now, once I do that, what I do is I count the number of the intervals which are there along this great circle between these 2 points A and B, and if you just count it, these will be 32 intervals. Now, each interval is representing 2 degree. So, we need to multiply that by 2. So, 32 multiplied by 2, which is the 64 degree. So, this comes out to be 64 degree. You need to just count these numbers. These intervals you have to count. Okay, just multiply that by the interval of your stereo net that you have taken, because here I have taken 2 degree interval stereo net. So, therefore, I am multiplying it by 2. So, the angle between these two lines is going to be 64 degree. Now, how we can determine the dip and the dip direction of this great circle? That means, this great circle corresponding to both the points, that is both the points they are lying on the great circle. What does that mean? Since the great circle represent a plane on the stereo plot, this will represent a plane which will be having both the lines A and B. Now, what is going to be the dip and the dip direction of that plane? So, you see what we do, how to determine that. What we do is, in this position where we have drawn this great circle on which A and B, both the points are lying, we draw a radial line in the this horizontal direction that is coinciding with this 270 degree. Now, the next step is from here to here is, so you see that you can measure from this point to this point, you can measure. So, you see that, let us do that, 10, 20, 30, 40, 50 and then 60. So, this distance, you see, if I just try to give you the idea, that is this distance, which is 60 degree in this case, this is going to give me the dip of this plane. Now, I rotate it back to this original position, that is north of the tracing sheet and 0 of the equatorial stereo net. They are coinciding with each other. So, wherever this line, so you see when I rotate it back, so earlier the north was here, so we just rotated it back in this direction. So, what will happen, that this line which was lying in this direction, it will get rotated in this direction. So, you see that it comes to this particular position, and then you can read that corresponding to this line, what is the angle on the stereo net. So, you see that here this is 180 degree, 190 degree and 200. So, its dip direction of this plane is going to be 200 degrees. So, this is how the angle between two specific lines can be determined. These two lines will be lying on a plane which is represented by a great circle like this, and following this procedure and this procedure, we can find out the dip and dip direction of this plane as well. Now, there is a alternative method of determination of the line of intersection of two planes. This we have already discussed using one particular method, but using the poles also we can find out the line of intersection of the two planes, because I mentioned to you that the planes can either be represented by great circle or they can be represented by their poles. When we represented it by great circle, then how to determine the line of intersection of two planes, that we have already seen. So, the alternative method is using the pole, how we can determine the two planes. So, you see that in this case again we are taking the same problem. Two planes are there, one is having a dip of 50 and dip direction of 130 degree, another one is having a dip of 30 degree with dip direction of 250. So, you see their poles have been drawn here. How to draw the pole? I have already explained it to you. Then what we do is, following the same procedure as we did in the previous problem, we rotate the tracing sheet in such a manner that these two poles, which are A and B, they lie on the same great circle. So, what will happen, that this great circle which has been drawn here by this dotted line, this will define the plane which will contain the normal to these two planes, that is A and B, because pole is representing the normal to that plane. Whatever is the distance of this from the center, that means this much. Whatever is this distance, you take the same distance from this outer circle, that is circumference, the same distance, this distance and this distance, they are the same. So, then we can locate the pole corresponding to this great circle. Once again, let us see, here I am taking whatever is this distance, say it is this distance, and I am taking this distance as the same distance. So, this is how I can find out the dip. So, this is what is going to be dip of this, and then the pole. So, this is the plane and this is what is your pole. This is how that we can determine it. Then because this pole defines normal to the plane which is containing these two planes, that is A and B. So, which is normal to both the planes. So, that will give us the line of intersection of these two planes. So, the pole of a plane which passes through the pole of the other planes define the line of intersection of those planes. So, please remember this. This is a very important statement, that is, pole of a plane which passes through the pole of the other planes, it defines the line of intersection of these two planes. So, you see one and the same thing. So, in the previous way, we first obtained these two great circles, and wherever it was intersecting, that was giving me the line of intersection of the two planes, and using the two poles, again we found out the same point as the determination of the line of intersection of the two planes. So, today we discussed about the determination of the line of intersection of the two planes using the two methods, followed by the discussion on how to determine the angle between the two lines. So, this is how we can represent the geological data which is 3D in nature, but on 2D, and this is how, using this graphical data, we can make use of this in the analysis of, let us say, tunnels or the slope stability or the foundations. So, in the next class, we will learn about some of the application areas of these geological structures and their graphical representation. Thank you very much.